On May 12, 2022, astronomers released an image of a supermassive black hole at the center of our galaxy, known as Sagittarius A-star. In this video, we'll answer the most popular questions about it. What is a black hole? A black hole is an incredibly dense space object with such a strong gravitational pull that even light can't escape it. Because no light can get out of the black holes, they are invisible. Astronomers detect them by observing their gravitational effect on stars and gas around them. Black holes can be of different sizes. The largest of them are called supermassive black holes. Why is the black hole called Sagittarius A-star? Sagittarius A is the region of strong radio emission at the center of the Milky Way. It is located in the constellation Sagittarius in the sky, hence its name. Within the Sagittarius A region, there is a smaller area where the supermassive black hole dwells. It was dubbed Sagittarius A-star to separate it from the larger region of Sagittarius A. The word star is just a way of reading the asterisk symbol. The asterisk simply indicates that the area is of special interest to scientists. What are we seeing in the image? The image shows a bright ring around a region of darkness. The bright area represents hot gas and photons swirling around the black hole at tremendous speeds. The dark area is where the black hole resides. The outer edge of the dark area is the event horizon, the boundary marking the limits of the black hole. Nothing can get out of a black hole once it crosses the event horizon. Is this an actual photograph of the black hole? Not exactly. A photograph is a recording of visible light that we can see with our eyes. The image of the supermassive black hole was created by recording radio waves that are invisible to humans. Using radio telescopes instead of optical ones allowed astronomers to peer through the hot gas surrounding the black hole. How was the image taken? Though Sagittarius A-star is 4 million times the mass of our Sun, its diameter is only about the size of Mercury's orbit. Plus, it is located very far away, at a distance of approximately 27,000 light-years. As a result, the black hole appears really small in the sky. Its angular size is equivalent to that of a donut placed on the surface of the Moon. To take an image of such a small object, the Event Horizon Telescope was used. It's a global network of 8 radio telescopes located all across the planet. Used together, they act as a giant telescope the size of the Earth. The petabytes of radio data collected by each of the telescopes were then combined to create one image of the black hole. How was the image produced? First, thousands of black hole images were sorted into several clusters based on similar features. Then, an averaged image was constructed for each of the clusters. Lastly, the final image was produced by averaging the pictures from all of the clusters. So what you're seeing is not the exact image of the black hole, but its averaged version. Why is the image so blurry? Remember the analogy with taking a picture of a donut on the Moon? Sagittarius A-star has an incredibly small size in our skies. To produce this blurry image, our Earth-based telescopes were pushed to their very limits. Plus, as Sagittarius A-star is comparatively compact, the material around it moves very fast, so producing a sharp image becomes quite challenging. It's something like trying to take a clear picture of a dog chasing its tail. Why is the image orange? The original image of the black hole is actually black and white. To make it easier for the human eye to pick out details in the image, the astronomers made it orange. The orange color has become the standard for the images taken at wavelengths longer than visible red light. For example, here's a recent infrared image from the James Webb Space Telescope. Why is this image important? The existence of a black hole at the center of our galaxy used to be only a theory. Scientists have been collecting evidence to support it since the 1980s. Finally, in 2020, Reinhard Genzel and Andrea Ghez received the Nobel Prize in Physics for discovering a supermassive object at the Milky Way's center. And now we have a picture of it. This picture is the final and indisputable proof that the central black hole in the Milky Way actually exists. Will JWST take a better picture of the black hole? Unfortunately, the powerful James Webb Space Telescope will not be able to see Sagittarius A-star. JWST's 6.5-meter mirror is tiny compared to the Earth-sized Event Horizon Telescope. The only ways to take a better picture of Sagittarius A-star will be to add more observatories around the planet or launch telescopes into space. The good news is 3 new telescopes have been added to the EHT recently. You can see them highlighted in blue. Let's hope we'll get a sharper image, or maybe even a video, of the black hole soon. Thanks for watching. If you have any other questions about Sagittarius A-star, please write them in the comments and we'll definitely answer. See you next time.